Jonathan and Tyler. They are token males. Be nice, ladies. What do you know about the male reproductive system? Jonathan didn't find that funny at all. What do you know about the reproductive system, male reproductive system?
Sperm.
Sperm. Yep, they make sperm. What are sperm?
Gametes.
They're called gametes. That's right, they are gametes.
It's half of their DNA.
Yep. And a gamete contains half of the DNA. What does she mean by half of the DNA?
The other half is from the egg,
It's
produced by the
24?
The chromosomes?
23.
23 chromosomes. We have 23 pairs of chromosomes. Right. So a gamete contains 23 chromosomes out of the 23 pairs. So half of 46. What else about the male reproductive system?
Testes.
Testes?
No one else is saying anything,
I
so.
think I have testes, testicles,
External genitalia.
external genitalia, and then internal genitalia. And the external genitalia is actually the scrotum and the penis. And the scrotum contains the testes. Yeah. What else?
Higher levels of testosterone.
Higher levels of testosterone
females.
than females. That's
Generally.
true.
Generally.
Generally speaking, that is very true, yes. And you remember that we actually produce some testosterone, female-wise, and that gets converted into estrogen in the adrenal glands, right? Yeah. All right, so we're going to be quiet about the male reproductive system. We know that the reproductive system is one of 11 systems, but have you ever thought about this? It's crucial to our existence as a species, right? Without the reproductive system, we wouldn't be able to make more of ourselves. But it's not crucial for the individual. And any woman that's walking around without her ovaries or her uterus or both can tell you, I'm living just fine. Not me, I still have my uterus and my ovaries. But women can survive and have done for years and years and years. Males can too. They can.
But even without the protective effects of estrogen, like bone density and
Yep.
things like that. And
It happens naturally though.
You might have a bit of a rougher time than.
It happens naturally.
yeah.
You can take hormone replacement therapy. I mean, it's gonna happen. Y'all, trust me. You are gonna lose your estrogen if you live long enough. You're gonna go through menopause. You have a whole other life post-menopause. A whole other life. It's very different. Yeah. All right, so it is not, the organs of the reproductive system are important. That's not to say that we don't need them at all. They are important. They are valuable. But we can live without our appendix. We can live without our spleen. We can live without our ovaries, our uterus, our
Kidneys.
Kidney can live without a
Singular
kidney.
kidney.
One.
Couple lobes.
You
of
can
the
live
lung.
without chunks of your liver. You know, you can grow a whole new liver. Crazy. Livers are replaced. I mean,
She said chunks of your lung too.
And a couple lobes of your lung, maybe take one lobe.
Yeah, no, the segments.
The segment I meant.
Not the whole lobe, because that's kind of hard on you. Losing parts of your
I
whole
think you would
the
just
whole lung.
deteriorate after.
They can
You can't
talk
take
out
one
to
of the
you.
lobes. I meant, okay, just like a small piece of your lung.
Yeah. All right, so the point is that the reproductive system is essential for the species. It's very important for overall health and development, for sure. It's just one of those, it's the only system literally that you can essentially do without the major parts of. Yeah. Now, the reproductive system is important for producing some very important hormones, especially in the developmental phase of life. So as you are reaching puberty and you hit, your mid-20s, those hormones produced by the testes or the ovaries, very, very valuable for making you feel good. In terms of males and females, we depend on estrogen for development. We depend on testosterone for development. We depend on estrogen and progesterone and testosterone for sexual drive. And without sexual drive, then there's no reproduction, right? So we need that part. I mean, there could be, yes.
Do you know if there's any research, this is probably relatively new, so there might not be, on people who term themselves asexual, do they have differing levels of those hormones, or is it something else that?
There's so many genetic variants that happen, Kesa. It's mind-boggling.
Yeah.
How many different genetic variants and mutations that can happen along the way. When we are talking, and I'll make this clear right from the get-go, we are talking basic biology here. Mm-hmm. We're talking male, female, XY. When you see, and you can do some research, I mean, it is extraordinary how many different mutations and machinations can occur between those two chromosomes. It's remarkable. We're going to talk about some of them, but I'm not even able to, I'm just touching the surface when we talk about the other things. But we're just talking about your basic biology here. Male, female. I could use feminized, masculinized. Would that make you feel better? Do you care?
No.
Terminology-wise? Male, female, right?
Yeah.
Okay, cool. Thanks. Lots of similarities between our systems, lots of differences between them. We will compare and contrast them as we go along. We're going to talk with the male first because the male system is a little less complicated than the female system. The male system produces gametes on a daily basis, making testosterone on a daily basis. The female system, very much more specific. Hormone, menstrual cycles, ovarian cycles, all of that gets kind of complicated. So we'll start with the male first. We have in the male reproductive system two distinguishing regions, the male external genitalia versus the male internal genitalia. The male external includes the penis and the scrotum, and the internal genitalia includes the testes that are housed in the scrotum, the epididymis that is housed in the scrotum, essentially sort of it caps the testicle. We have a tube called the ductus deferens or the vas deferens that carries sperm from the testes and epididymis to the vagina. And the seminal vesicles, prostate, and the bulbourethral gland, these three glands provide the fluid that sort of bathes the sperm and carries the sperm on their journey, wherever they're going. If they're either going out into the environment or they're going into a vagina or into a
Toy.
yeah, something like that. All right, so we got scrotum is external and everything else is internal. The organs themselves, right, the testes is considered the primary organ, and the testes produce the sperm and they produce testosterone. And then all of these other structures considered secondary are about storing the sperm, allowing the sperm to mature, providing them some survival skills, and then the release of that sperm. And sperm can live quite a long time within the testes and the epididymis. And if they're not called upon within like 3 months, they are then resorbed. And we go on to producing, replacing them. So there's constant replacing of sperm on a daily basis. Yeah. So our male reproductive system is going to produce testosterone, and testosterone is what's going to provide for those secondary sex characteristics that develop in males. The testosterone production begins at puberty, somewhere in the age of 12 to 13, maybe 11 in some that are really, what's the word I'm looking for? Premature, yeah. Some of the things that are different between males and females is, of course, those distinguishing secondary sex characteristics, those structural characteristics. But we all develop axillary hair and pubic hair, which also come with these secondary sex characteristics and the hormones that promote their development. So they're referred to as dimorphic. In other words, we both produce pubic hair and we both produce axillary hair. Males are a larger skeleton. I think it's easy to understand. Broader shoulders, narrower hips, more muscle. We talked about that when we were talking about fluids. Remember, more muscle versus more adipose tissue. A laryngeal prominence, where is that?
On your thyroid.
On your thyroid cartilage, yep. More body hair on males than females, more facial hair on males than females, and that deeper voice. And do you remember, did you ever hear this story about in Roman times, they would value the young boys' high-pitched voice and castrate them to maintain that so that they could sing in the choir and maintain that higher voice in the choir. Males produce these large skeletons, and females use these things to decide who they like best. Because females do the selecting. Girls, I should write this one down. We do the selecting.
Have you seen male birds perform for the female birds?
Hmm?
Male birds, they do a dance for the female birds.
Yeah, the bowerbirds. Have you seen those videos of the bowerbirds? That's amazing what they do. I know, bless their hearts. And so we are all familiar with this, right? We know that females, the female, biologically speaking, carries 2 X chromosomes in her, not ova, because the ova only carries 1, but all of her other cells carry 2 X chromosomes. When that oocyte is fertilized by a sperm, the sperm might be carrying an X chromosome. That's going to result in the development of a female. Males carry XY in their cells. They have 1 X chromosome, 1 Y chromosome. Their oocyte that was fertilized by a Y-carrying sperm results in a male. Where does this happen, this producing oocytes and sperm? What's that process called? Meiosis. Meiosis. Yeah. Do you understand meiosis? Yeah? If you are at least the least bit foggy about it, because I've discovered that students tend to think they understand it, but they don't really get both phases, right? There's meiosis 1 and meiosis 2. I have in our shell 3 ways that you can appreciate the difference between meiosis and mitosis. And I encourage you to go back and just review that. There's also a really great video called The Miracle of Life. And it's an older video, but oh my goodness, it's so good to remind you how these 2 systems, the male system, the female system, work and produce us. So take an hour, 50 minutes, watch The Miracle of Life. If you haven't seen it before, you'll appreciate it. If you have seen it before, it's kind of a nice review. But by all means, review your mitosis-meiosis linkage and how meiosis differs from mitosis. So you know that you have an oocyte that's fertilized by a sperm carrying an X chromosome. You make a female, you have an oocyte carrying an X chromosome fertilized by a Y sperm. You make a male. It's a 50-50 chance every time we get those 2 together as to whether or not it's going to produce a male or a female. When you were in the womb, when you were in the uterus, early days, like prior to 6 weeks even, you all looked exactly alike. Male, female, everybody looked exactly as alike. There are certain structures that correspond to the overall development of the reproductive system. And we see here that we have a mesonephros. This is a pre-kidney. We have a gonadal ridge. This gonadal ridge becomes part of the testes or the ovaries. We have the mesonephric duct and the paramesonephric duct, and these are going to become the duct systems or even the uterine tubes. The duct systems or uterine tubes on an individual should they become a male versus a female. And what is it that distinguishes, and how do we turn for this into this or this? This is the most interesting part. So on the Y chromosome, there's a section called the SRY gene. And the SRY gene has to be turned on in order for the male reproductive structures to take hold, to develop. so sex determining region of the Y chromosome, codes for this testes determining factor, which is a protein that alters the gene expression and causes the development of male reproductive structures. So the paramesonephric duct disintegrates, the gonadal ridge develops into the testes, the mesonephric duct develops into the duct system, so the vas deferens. Whereas if this SRY gene is not turned on, then there's no drive to produce these structures. That means that the mesonephric duct does not develop, and the paramesonephric duct does develop. And though we still have the gonadal ridges, they develop into the ovaries. You can see that this, then the paramesonephric duct becomes the oviducts, and also the uterus. Now, this can happen. You can have an XY cell-bodied person, but that SRY gene doesn't get turned on.
Literally just about to ask.
Then what happens?
Hermaphrodite, right?
No.
No, they're born as female.
You're born as female.
Yeah.
You have external female structures, you look like a female.
Mhm.
This is a problem when they're doing genetic testing of female athletes. Because you can have a female athlete that is XY, has no idea she's XY. She identifies as female because she's got breasts, got a uterus, ovaries. But her cells are carrying XY. Crazy,
So then
right?
how do hermaphrodites happen? Is there
Hermaphrodites,
different-
yes, so there's other things,
Different things happening?
so many other things can happen.
Okay.
So one of the problems with this not getting turned on is called the Swyer syndrome. I have some notes on it. 1 in 80,000 can develop this condition, where you have 46 chromosomes, XY, but the SRY gene is not turned on, so you get your female primary and secondary sex characteristics. There are a couple of other gene variants that can be a cause of it, and you may look female outward, but the ovaries are small, non-functional, and you have no puberty, and it's 1 in 80,000 births that can develop this Swyer syndrome. So even though you may think you're female, but you have nothing working for you.
I feel like Jamie Lee Curtis or someone has something like that, and so she couldn't actually have children. She has to adopt. That because of something similar.
Because she
to
had no
that.
puberty, she didn't develop any of her secondary sex.
Or no. She had. I think she's like XXY or something like that.
Oh, one of those.
Yeah.
Yeah. There's a whole, all kinds
Whole
of
host
different.
of.
Because remember, during meiosis, this first phase of meiosis, this prophase 1, is critical for getting the separation. And then we have so you got your crossover piece, and then you have that independent assortment piece. And in both of those situations, you can have mix-ups. And when it happens to the X and Y chromosome, it's really devastating. Yeah. So we have this 5 to 6 week embryo. We get this differentiation. We can go either male or female, and it's the male, the SRY gene on that Y chromosome has to get turned on in order to develop male internal genitalia. The testes start producing testosterone, and that testosterone is also an important part of continuing this male development, because along with the testes, inside the testes, there are these specialized cells called sustentacular cells, or nurse cells. And the nurse cells are critical for the continued development from the spermatogonium to sperm. And when I say critical development from spermatogonium, the spermatogonium are 46 chromosome containing cells. They are you know the word I'm looking for?
Diploidy?
Diploidy. Diploidy. Yes, they're diploidy. Where did that come from? That one. So these sustentacular cells, they secrete this Mullerian inhibiting factor, which continues with the disintegration of those paramesonephric ducts. Without that stuff, female development occurs. Without those androgens that the testes would be starting to produce, early on in this developmental process. Again, you need that SRY gene in order to get that all happening. Even as this is all happening, you can do an ultrasound and still not know what the sex is of the fetus that you're carrying, even at 12 weeks. So it takes as much as 20 weeks in order to differentiate them externally, because this is what we were going to see externally. We're not going to see these things happening, right? We're going to see whether or not we have a glans penis. And whether or not we have a glans penis is going to be determining, right, male from female. Well, guess what? You can have a glans penis, but you also have a glans clitoris. They're the same. They're two structures coming from the same developmental process. We have a urethral groove, both male and female. Notice that our anus, same tissue, both male and female. But then we have this differentiation where we go from this urethral groove to this perineal raphe that separates especially the two sides of the testes. So they'd be looking for your glans penis versus gland clitoris, and then obviously looking for the development of testes and the the shaft of the penis versus the vaginal lips, the labiosacral folds. Now we're on to structures that we're more familiar with. Right. So we're going to talk about the scrotum first, and that is one of the two external genitalia structures, the scrotum and the penis, external genitalia. And the scrotum is essential because it houses the testes. And by houses, I mean it literally holds the testes. The scrotum is two sacs, really. There is a connective tissue septum that separates these two sacs, which means that you can have damage to one testicle and not impact the other testicle, which is great. So you can have cancer of one testicle, not the other testicle, which is valuable. Damage or disease to one or the other, which is good. The scrotum is a skin sac, and it contains an important little muscle called the dartos muscle. Here it is. Gabby?
Yeah.
See it in the skin?
Mm-hmm.
So the dartos muscle is a smooth muscle contained in the skin of the scrotal sac. It's going to be important for thermoregulation. And as you'll hear and learn, the testes are very, very testy. They want to be at just the right temperature all the time. Where we're operating at like 37 degrees centigrade, the testes want to be at 35 degrees centigrade. They don't want to be too warm, they don't want to be too cold. So the scrotal sac contains our testicles, and it has within the skin of the scrotum a smooth muscle called the dartos muscle, and the dartos muscle causes the skin of the scrotum to shrink and wrinkle. And by doing that, you lose surface area, whereby you don't lose as much heat. So if the testes are cold, the dartos muscle causes a shrinkage and a kind of a taunting of the skin of the scrotal sac and pulls those testes closer to the body, thus keeping them a little warmer. The cremaster muscle, not within the scrotum, not within the scrotal skin itself, but within the scrotum itself, is another muscle. This muscle, this cremaster muscle, is actually a continuation of your internal obliques. So it's skeletal muscle, but it's not a voluntary skeletal muscle. It's not one that you can say, contract for me. But it's important because it does pull the testes up toward the body wall if the temperature is too cold for the testes. It relaxes if the temperature is too warm for the testes and allows them to get farther away from the body wall and farther away from that body heat. There is a cremaster's reflex. I've not been able to elicit it. I imagine that somebody might someday, but it does apparently exist if you were to stroke the thigh of the individual with the scrotum containing the cremaster muscle. So the scrotum contains the testes, and it also contains a number of other structures up through something we call the spermatocord. And the spermatocord is a continuation of the structures within the scrotum itself. The testes, contained within the scrotum, where sperm is made, where testosterone is made. And as we already said, they like to be at just the right temperature. And there's several terms that you might hear. I use the word testicle. Testes, plural. Testis is another word for a singular testicle. Now, the testes have two jobs. One is to make sperm. That's considered their exocrine function. And the other is to make androgens. I think testosterone all the time. And that's the endocrine component for the testes. So they are making the hormone that makes males male-ish, testosterone. The testes are connected to the body via a structure called the spermatic cord. And the spermatic cord contains multiple structures within it. One of those structures that the spermatic cord contains is the ductus deferens, or the vas deferens. You may have heard it one or the other way. It also contains blood vessels, both testicular arteries, testicular veins. It contains nerves and lymphatics. It's got the cremaster muscle, and it has something else that's important for thermoregulation called the pampiniform plexus. And we can see it here, this netting of the blue vessels, which would be venous, almost like capillary beds, but they're little venules really. And deep to them is another netting of blood vessels that are arterial-like. And what happens is that you get a transfer of heat from the blood coming out of the body wall to the venous system to go back to the body wall. Rather than bringing all that nice warm blood down to the testes, remember, they don't want to be that warm. They want to be lower temperature than the body is. And so we have this countercurrent heat exchange via the pampiniform plexus. The spermatic cord does set males up for something called testicular torsion. So you can have a twisting of the testicle and a twisting of the ductus deferens and all the blood vessels and nerve and lymphatics. So you can see there'd be problems with that. Yeah.
What
Lovely.
does happen when that happens?
Why does it happen?
What happens when
Oh,
that
so
happens?
hopefully it's recognized right away and go in and fix it. Untorse it.
And if it's never recognized?
No, it hurt.
It'll kill that testicle for sure. Yeah, and it'll hurt. Yeah. Just a little higher view of your pampiniform plexus. You can see how it is going to be taking heat away before it ever gets to the testes, because the testes, again, want to stay nice and cool. When I was a kid, tight pants was the fashion statement for both males and females. And males would wear these really tight jeans, and they were discovering that sperm counts were going down. And sperm counts were going down because the testes were being held too close to the body. They were too warm all the time. So this is the last thing I'm going to talk about because I got to get on the road. We have within the testicle a very important structure called the tunica vaginalis. The tunica vaginalis is a serous membrane. They have not distinguished one layer from the other. We just know that this is the tunica vaginalis that covers the outside of the testes. And then deep to the tunica vaginalis is another structure called the tunica albuginea. And here we're looking at the tunica vaginalis, this one, superficial. And if this is a serous membrane, what's the function of it?
Pretty serious fluids.
Serous fluid, and therefore the testes have a little bit of freedom of movement to roll and slide, right? The testes are comprised of multiple lobes, and within the lobes you have seminiferous tubules. These are tortuous, they're twisty-turny. We're going to look at them more closely when we get back together on Wednesday. These seminiferous tubules are where we make the sperm, and tucked in between them we have pieces of this tunica albuginea tucked up and making little septums between the lobes. And tucked in there are cells called interstitial cells that produce the testosterone. And this is, like I said, where we're going to bag it for today. And then we will see you